yesterday we talked about permutation where order matters. So much like a license plate, much like a password, if we were to choose a password and we had the letters A, B, C, and D, and we needed to choose 3 letters for that password, let's list out all the possible passwords we could have. Well, we could have A, B, C, A, C, B, and so on. We could list all of these out. I've already done that for you and listed them out here. Now, that would be all of our permutations. If you notice, some of the letters do overlap in the same ones. We have ABC and we have CBA. Those both contain all 3 of the letters ABC. Well, today we're going to talk about combinations. And when we talk about combinations, we talk about it where we want to cross out that overlap. We do not want any overlap to be there. So we want to cross out all these overlaps because those won't count because order doesn't matter when we talk about a combination. If we have the letters A, B, C, we count those only one time. So if we look at it and we take the letters A, B, C and we cross out every time we see those letters as ACB, as BAC, as BCA, as ACAB, as CBA. And we cross out all of those. And if we go through the next one, ABD, anytime we see those 3 letters occur again, we need to cross those out. So we cross out all of those. And now, let's go to the next, ACD. We see the letters A, C, and D as in ADC, CAD, CDA, DCA, and ACE, or DAC, sorry. Now, let's go to the next one we see here, and that is BCD. Anytime we see those overlap, and they're going to be all of our remaining. So if we look at our combinations here, when we take these 4 letters, we're only going to get 4 possible combinations because we don't want those overlaps. We only want to count it when we see the letters ABC one time. We see the letters ABD. We only want to count that once. And that's how we talk about combinations. Now let's look at that formula for a combination. The formula for a combination looks very similar to the permutations that we studied yesterday, except for we have in this extra R. Now when we talk about this extra R, we talk about what's going to happen. Well, that's going to cross out all of those overlaps. We want to get rid of the overlaps that we just saw here in our problem where we scratched out all of these. We want to scratch out all of these overlaps. Well, to do that, we add in this R in the denominator because that divides them out. So let's look at an example. Well, before we look at an example, let's recap about a factorial. Remember, if we have 5 factorial, that's going to be 5 times 4 times 3 times 2 times 1, which is going to give us 20 times 6 times 1, which is 120. So don't forget that a factorial, we start with the number that's there and we multiply down going until 1. So if we have an example that says that we have 10 items and we're going to choose 6 of them to put in a combination. Because remember, we have here what we're going to take and how many we're going to choose still, just like yesterday. So we have 10 total items, so we take 10 minus 6, and then we put a 6 factorial over here because those are going to cancel out and get rid of all of those overlaps for us. So we have 10 factorial on top. 10 minus 6 gives us 4 factorial times 6 factorial. Now, the way I like to look at it is we take the larger factorial in the denominator. And we want to make that factorial on the top. So if we do that, and we take 10, 9, 8, 7, well, the rest of them down are 6 factorial. We take 4 factorial times 6 factorial. Now, in the numerator and denominator, we can cancel out the 6 factorials because 6 factorial over 6 factorial is 1. And now we have 10 times 9 times 8 times 7 divided by 4 times 3 times 2 times 1. Well, 4 times 3 times 2 times 1 is 24. And when we multiply out 10 times 9 times 8 times 7, that gives us 5,040. And when we divide that, we will get 210. So we have 210 combinations when we take 10 items and choose 6 of them to put together. Now remember, there's going to be no overlap there. Order does not matter. So where is this going to be in the real world? Well, the greatest example I can think of is a pizza. When we go and we see the toppings, onions, green peppers, mushrooms, pepperoni, pineapple, and ham, does it matter how you order it? Well, you got to order the toppings you want. But if you were to choose and you wanted, let's say, a pineapple and ham, which a lot of people call Hawaiian, doesn't matter whether you say ham and pineapple or pineapple and ham. No, because all of that is going to make one pizza. So here, it doesn't matter the order that you say it in. You're going to get the same pizza. And that's why in a combination, order doesn't matter.